This is Pre-Calculus, Part 1, Section 4.1, Angles and Radian Measure, Example 8, Finding the Length of a Circular Arc, on page 470 to 471. The good news is this formula, it's the only formula there is for finding the arc, and it's very simple. It's literally radius times the angle. The catch to it is that the angle has to be in radians. You can't use degrees. So if you start out with degrees, you have to convert it to radians first and then multiply by the radius. Okay? So a radius has a circle of 10, said that backwards. A circle has a radius of 10 inches. Find the length of the arc intercepted by a central angle of 120 degrees. Okay? Again, can only be used when it's in radians. So we have to change that 120 to radians. Remember, if it's radians we want, that's what goes on top. So it's pi over 180. So it's 120 pi over 180. And if you reduce both 120 and 180 reduced by 60, and you get 2/3 pi radians. Once it's in radians, you just have to multiply by the radius, which is 10 inches. So 10 times 2 pi over 3 is 20 pi over 3 inches. And if you multiply that out on your calculator, it's about 20.94 inches. Okay, which makes sense because pi is 3.14, so it's almost 3. 3 over 3 is 1, so it should be around 20, give or take. So for the checkpoint, it says, has a radius of 6, and the length of the arc intercepted by a 45-degree angle. Okay, so the first thing we have to do is change 45 to radians, which means we're going to multiply by pi over 180. So 45 pi over 180. They both divide by 45, so that's, I believe, pi over 4. Okay. Now that we have that in radians, we just have to multiply it by the radius, which is 6 inches. So we're going to do pi over 4 times 6 inches, which is 24. Oh, I'm sorry. 3 pi over 2. It said it wanted it in terms of pi, so let's see. Did I do that or no? Oops, sorry. So this would be equals 6 pi over 4, which reduces to 3 pi over 2. Oops. And then when you calculate that out, it's 4.71 inches. Okay.